So hello guys, welcome you all to the next video. So today will be the Q&A session and we'll have the first unit, that is we'll discuss about the semiconductor and diode, some questions. We'll be doing some multiple choice questions. These will be the probable questions in your BTech examinations, in your offline as well as your online. Multiple choice questions will be from these areas. So guys, let's start with the multiple choice questions from the unit 1, that is semiconductor diodes. So here we go with the first question, and the question says the arrow direction in the diode symbol indicates dash. So the options are direction of electron flow, direction of hole flow, opposite to the direction of hole flow, or none of the above. So as we know, the arrow direction, if the diode is in forward bias, the arrow direction indicates the direction of the current flow or the direction of the hole flow. So this B is the correct answer, that is direction of the hole flow. So let's move on to the next question, that is the knee voltage or the cutoff voltage of silicon diode is dash. So you guys know it is 0.7 volts. It's 0.7 volts, so it's option B. Now moving on to the next question, when the diode is forward biased it is equivalent to dash. So as I said in the earlier lectures, that when the diode is in forward bias it behaves as a short circuit or on switch. So the answer is on switch, because when the switch is on it behaves as a short circuit. So moving on to question number 4, that is under normal reverse bias voltage applied to diode, the reverse current in silicon diode is dash. So the answer is order of microampere, because when the in reverse current in silicon, if you are considering silicon, the reverse voltage the reverse current is very low, so it will be in the order of microampere, which is the lowest among all these four options given. Now moving on to question number 5. An avalanche breakdown in a diode occurs when dash. Option A, potential barrier is reduced to 0. B, forward current exceeds certain value. C, reverse bias exceeds a certain value. Or D, none of the above. So here the answer is C, reverse bias exceeds a certain value, because when the reverse bias, as we have seen in the zener diode lecture, when the reverse bias increases from 4.3 volts or above, the reverse breakdown or the avalanche breakdown occurs. Now moving on to question number 6. Reverse saturation current in a silicon PN junction diode nearly doubles for every dash. A, 20 rise in temperature. B, 50 degree rise in temperature, 60 degree rise in temperature, or 100 degree rise in temperature. So the answer is D, 100 degrees rise in temperature. This is a completely theoretical concept. You need to remember this, 100 degree rise in temperature. Now moving on to question number 7. A forward potential of 10 volt is applied to a silicon diode. So here we need to calculate it. So let's observe this. So here the question says that a forward potential of 10 volt is applied to a silicon diode. So we have a silicon diode here and we have a forward potential of 10 volts. So in the second statement it written that a resistance of 1 kilo ohm is also in series with the diode. So there is a resistance of 1 kilo ohm in series. So here is the circuit. This is the conditions given. Now let us see what's the question. The question is the current is dash. So first, in order to calculate the current, we need to see the voltage across this resistance. So the 10 volt goes through this diode. So we know that the silicon diode provides a voltage drop of 0.7 volts, as I have taught you in earlier lectures. So this 10 volts will become 9.3 volts. So the voltage across the resistor will be 9.3 volt, and the resistance is 1 kilo ohm, that is 1000 ohm. So we need to find out the current. So according to Ohm's law, V equals to IR. So your I equals to V divided by R, that is 10 volts divided by 9.3 volts divided by 1000 ohm, that is 9.3 milliampere. That is the second option, 9.3 milliampere, B. So it is the correct answer. Moving on to the next question, that is barrier potential at room temperature is 25 degrees Celsius is 0.7 volts, its value at 125 degrees Celsius. So this question also we need to observe on the board. So here we go. So here the question says that the barrier potential at room temperature, that is 25 degrees Celsius, is 0.7 volts, and it is asking what will be the barrier potential at 125 degrees Celsius. So we know that the barrier potential drops at the rate of 2.5 millivolt per degree Celsius. So here is the temperature drop of 100 degrees Celsius. So for a temperature drop of 100 degrees Celsius, there will be a voltage or the barrier potential drop of 100 degrees Celsius into 2.5 millivolt per degree Celsius, that is 2.5 millivolts. So this drop will be 2.5 millivolts, and the new barrier potential will be 0.7 volts minus 2.5 millivolts, which will be 0.45 volts, or which can be approximated to 0.5 volts, which is the option A. Now moving on to question number 9. When a reverse bias is applied to a diode, it will dash A. Rise in potential barrier, B. Lower the potential barrier, C. Increases the majority carrier current greatly, yet D. None of the above. So the answer will be raise the potential barrier. When a reverse bias is applied to a diode, it will raise the potential barrier, and this is the reason why by applying a reverse bias to a diode for a longer amount of time will break the, after raising the potential barrier to a larger amount, it will break the potential barrier, and that moment the diode or the PN junction will be broken or destroyed. Now moving on to question number 10. The best description of Zener diode is that dash A. It operates in reverse region. B. It is a constant voltage device. C. It is a constant current device. Yeah, D. None of the above. So the best description of Zener diode is that it operates in reverse direction. Why? Because constant voltage device can also be other constant voltage devices, but the main operation is that it operates in reverse region. So A is the correct option. Now moving on to question number 11. The LED is usually made up of dash. So the options are, these are the options. So the answer is C, that is gallium arsenate. So LED is usually made up of gallium arsenate. So C is the correct answer. Now moving on to question number 12. The PN junction photodiode operates dash A. First forward biasing the junction and then illuminating it. B. First reverse biasing the junction and then illuminating it. C. First illuminating the junction and then reverse biasing it. Or D. First illuminating the junction and then forward biasing it. So the correct answer is B. First reverse biasing junction and then illuminating it. Now moving on to question number 13. It says that testing a good diode with an ohmmeter should indicate dash. A high resistance when forward or reverse biased. B. Low resistance when forward or reverse biased. C. High resistance when reverse biased and low resistance when forward biased. Or D. High resistance when forward biased and low resistance when reverse biased. The answer is C, that is high resistance when reverse biased and low resistance when forward biased. Now moving on to question number 14, that is a PN junction allows current flow when dash A. Both the N-type and P-type materials have the same potential. The N-type material is more positive than the P-type material. C. The P-type material is more positive than the N-type material. Or D. There is no potential on the N-type or P-type materials. So the answer is B. That is the N-type material is more positive than the P-type material. Now moving on to question number 15. The diode used in 7-segment display is dash. A. Zener diode. B. Photodiode. C. LED. Or D. Laser. So the answer is C, that is LED, because 7-segment display provides 7 LEDs placed in the process or in a display which represents a 8 structure where erasing some or switching on some lights and switching off some lights could provide a complete display of all the numbers and letters. So it's LED. Now moving on to question number 16. The diagram shown below corresponds to dash. So here you could see a diagram. CB represents the covalent bond and VB represents the valence bond and FB is the forbidden valence or the forbidden band gap. So the options are the single energy level of an electron, B, the discrete energy level of an electron, C, the energy transfer diagram, or D, the energy band diagram. So it is the energy band diagram, that is the option D. Now moving on to question number 17. The space between the outermost filled energy band and the next empty band is called dash. A. Valence band, B. Conduction band, C. Forbidden band, or D. None of the above. So the correct answer is forbidden zone, the option C. Now moving on to question number 18. Dash the forward bias resistance of the diode is dash than its reverse bias resistance. So both the answers should be same. So the options are larger, double, smaller, or none of the above. So the answer is smaller. So the sentence will be smaller the forward bias resistance of the diode is smaller than its reverse bias resistance. Now moving on to question number 19. A zener diode is operated in dash. A. Breakdown region, B. Forward characteristic region, C. Zero biasing, or D. None of the above. So the answer is A. Breakdown region. We have studied in the earlier lectures, zener diode operates in breakdown region. Now moving on to question number 20. If the PN junction diode is heavily doped, then breakdown voltage will A. Increases, B. Decreases, C. Remains the same, or D. None of these. So the answer is decreases, If the PN junction diode is heavily doped, then breakdown voltage will decrease. So the correct answer is B. Now moving on to question number 21. Solar cell works on the principle of dash. A. Photothermal conversion. B. Photovoltaic conversion. C. Electron pumping. Or D. None of these. So the answer is photovoltaic conversion, because photovoltaic means it converts photons or light to voltage. So that is the main principle of solar cell. It converts solar energy or the light energy, solar light, into voltage. So B is the correct answer. Now moving on to question number 22. For artificial satellite, the source of energy is dash. A. Fuel cell, Edison cell, solar cell, or biological cell. So of course it is not biological cell. So the answer is solar cell. For artificial satellite source of energy, the solar cell is the power source. Now question number 23. The electrical behavior of a solid material is determined by dash. A. The energy band gap. B. The energy levels of the inner shell electrons. C. Zero biasing. Or D. None of these. So the correct answer is the energy band gap. The electrical behavior of a solid material is determined by its energy band gap. Now question number 24. The barrier potential of an unbiased silicon junction diode at room temperature is dash. So it is also 0.7 volts without any doubt. So the answer is option B. Now question number 25. A zener diode is used as a dash, half wave regulator, half wave rectifier, voltage regulator, or D, amplifier. So the correct answer is voltage regulator. We had also done that example in zener diode lecture. You can refer to that lecture. It behaves as a voltage regulator circuit or voltage regulator. Now question number 26. In operation, a photodiode is dash. A. Unbiased, or B. Always forward biased, C. Always reverse biased, or D. Either forward biased or reverse biased. So the correct answer is always reverse biased. Now moving on to question number 27. A photodiode is used in dash. A brake indicator, optocoupler, a regulated power supply, or a logic gate. So the correct answer is an optocoupler. A photodiode is used in an optocoupler. Now question number 28. The acronym LED stands for dash. Light energized diode, light emitting diode, low energy device, or low energy dynamo. So the correct answer is light emitting diode. As we know, LED is a diode. It emits light when in forward bias condition. So it's light emitting diode. Now question number 29 says that by adding dash impurity in intrinsic semiconductor, P-type semiconductor is made. A. Trivalent, B. Pentavalent, C. Quadrivalent, or D. Divalent. So eliminate these two options because quadrivalent and divalent will never make a semiconductor. So we have studied in the first lecture itself that by adding an trivalent impurity in intrinsic semiconductor, P-type semiconductor is made, and pentavalent impurity makes a N-type semiconductor. Now moving on to question number 30. The charge on P-type semiconductor is dash. A. Positive, B. Neutral, C. Negative, or D. Either positive or negative. So the correct answer is neutral. The charge on P-type semiconductor is neutral. Now moving on to question number 31. Dash from the following semiconductor diodes, only dash operates in forward bias only. From the following semiconductors, which operates only in forward bias? A. LED, B. zener diode, C. photodiode, D. None of the above. As we know, photodiode does not operate in forward direction mode. Zener diode operates both in forward and reverse direction mode, but LED Only in forward direction this LED glows. So correct answer is LED. So guys, today in this video we had discussed about the question and answers or the multiple choice questions of the unit 1, that is semiconductors and PN junction diodes. So there will be another Q&A video regarding the rectifiers and transistors. So if you find this video informative, please hit the like button and comment below if you have any doubts regarding the topics, and subscribe the channel